Hey guys, welcome back to AlgoYogi. We are doing two pointers approach and two pointers series. I'm not gonna start re-recording. I'm gonna keep it going. So our next problem in the list is container with most water. So let's go to the problem on LeetCode. You are given an integer array, height of length n. There are n vertical lines drawn such that two endpoints of ith line at I0 and I, basically the length, I height, that value at that index. Find two lines. Basically they're talking about these two lines. Oh, you can't see it because you can see my beautiful face over there. This is the Hank from Breaking Bad. If you have seen it or if you haven't seen it, that's how he does it. I'm watching it right now. It's a pretty cool character. Yeah. So these are the lines that we are talking about. So we are given an array, and at every index we are given a value, which is basically the height of the value. Now we need to find two of these lines where maximum amount of water between those two lines could be contained, right? That's as simple as that. That's the question. And I'm sure if you're coming to this video that you already understood the problem, and we are here to just have fun and so gonna solve it, right? Yeah, we're gonna write the solution. Okay, let's understand how we're gonna do it. So since we just need to find, we need to return the maximum amount of water that we can contain. Water in this container can store. Yes, container can store. It's like we gotta make that container choosing two lines basically. So that's what's gonna happen, right? So yeah, let's understand. Please skip through if you just directly wanna reach to the solution. Okay, let me move it over here so we can see it properly. So we are given this array. This is the array basically, and each value that you see over here is basically the height. So this corresponds to this, 8 corresponds to this, and 6 is here, 5, 4, 3, 7, 3, 8, or whatever. Now we need to find these two lines where between those two lines most water could be contained, right? The maximum water could be contained. So how we calculate the amount of water, which is the volume, and that will be calculated by taking the minimum of these two lines. So we have to find the minimum of those two lines that we are choosing, and then multiply it with the distance between those two lines, right? So let's say in this example they have chosen this line and this line. What is the minimum of these line? Is this one, which is 7, and 7 was multiplied by this distance. So this and this. So basically this was since it's the length of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this must have been the 8th index. So 8 minus, this is the first index, minus 1, and that is basically giving us 7. That is the length from this line to this line, and then minimum of these line is this one. So 7 into 7 is 49. Okay, so that's the answer right here. All right, that's the answer right here. Now we understood what we need to do. Now let's find out how we're gonna do it. Oh my god, I'm having too much fun today. So how about we just use the brute force approach, and since we need to choose two lines, and they cannot be same, right? Then otherwise the water contained between just one line would be 0, and we don't want 0, we want the maximum water, right? So we're gonna do a two for loop approach where I starts at 0 and j starts at I plus 1, which is 1, and then it keeps for we're making combinations of these lines, of these different values, and we calculate the water, and we have this result array, sorry, not array, result value, and we just basically update it with max previous result value or the amount of water we are calculating between these combinations of lines. That would be a brute force approach, and it will be of big of n square time complexity, right? But we're doing 2 pointers approach, so we can definitely do better, and that would be basically bringing down that n square time complexity to big of n, and space complexity it was always constant. So how do we do it? Since it's about finding these at the maximum distance from each other and the maximum height of these two lines, right? So how about we have 2 pointers? One is pointing to the beginning and another is pointing to the end line, basically. So right now, this is, let's say this is I and this is basically j, and right now they're pointing to basically first and last value. And now we're checking if what's going to be the amount of water that is going to be contained within these 2 lines. That will be the index of this minus index of this, so j minus I multiplied by minimum of these 2 lines. What is that? So 7 and 1, what's the minimum? 1. So you multiply that, and then j is basically at 8. 8 minus 0 is basically 8. 1 into 8 is 8. That's the maximum water that we contain right now. But we know that I'm sure we can contain more water, right? Like if we choose different values, right? Or less water, I don't know. So what I'll do is this I'll keep because it's the biggest value, and I will move forward I in order to find a bigger line, right? So the decision here would be move the pointer that's pointing to the lower value in a hope that you might find a bigger value next to it, or keep moving one of these pointers so that, like, although they're moving closer, the distance is decreasing. However, height might increase so that we could take a higher height of from these values so that we can contain more water. See, the amount of water increases both ways. Right now we're giving it the maximum distance, maximum width, but the height might have been little lesser in one of those values, so we just move them closer. And that's what, my friend, we are going to do. And we just keep moving these values closer depending on whichever index is pointing to the least value or lesser value, and then we keep bringing them closer until we basically point to the same one. Then you break out of the loop. That would be basically while loop, and I think that would be it, and that will bring down the time complexity of this problem to big of n from brute force solution big of n square. Okay, so I guess it's time to write the solution. Enjoy, guys. Everyone here is just so serious. Why? These problems are here. They're not running anywhere. Just relax, sit down, solve them. What's up, my gang? Welcome to it. Okay, so as I said, we're gonna have a result. Then we're gonna have I and j. So, or you know what would be better? Let's call them start and end. That's that would be better. Start at 0 and end is starting at basically the end of this array. So len height, but we want to point to the real index. We don't want to point because index starts at 0, so let's point it to decrease it by 1 so that running out of the index. And while start is lesser than end, until then, what we want to do is we want to update our result. What is our result? Max of previous result. We want to return the maximum value, or we want to find out the volume of water that will be within the current pointers. So that would be the width. How are we finding width? End will be pointing to the last index, end minus start, right? That's giving us the width, and that will be basically multiplied by the minimum of the one of these values. So heights, sorry, not heights, height, GHT, height start, or height end. Okay, height start or height end. That is it. Now that will update our answer, but now we need to make a decision which one, which pointer we want to move, and we want to obviously move the one that has the lesser value. So if I'll say height start is lesser than height end, then I will move forward my start, right? Else I will bring back my end. Okay, that's it. And then finally I will just return my answer, which is result. Okay, so let's go over it again. And I am sure I should have moved it to this side. Must have been distracting. Ooh, now it looks beautiful. Okay, so what must have happened is we have this result, 2 pointers pointing to the front and back. Then we keep bringing them closer until they become equal. Keep updating our answer with the max of result or end minus start into minimum of start and end, and then comparing the values of start and end, and increment or decrement start and end respectively, which one is shorter, right? If start is shorter, then move start, otherwise move end, you know. So that my friend is the wrap. Let's zoom out and submit it. Boo! Yeah. Let's submit our answer. We're gonna do a lot of coding. We're gonna solve every single problem here. Right? Yeah, submit it. Oh, I don't know what I did. It's accepted, guys. Yeah, so let's write the time complexity, which is big of n. We brought it down from the brute force approach, and it's so simple. We have written so many problems, and we are going to do 500 problems this year. Started in January, and we're gonna kill it. You know, time brings prosperity, discipline brings money. No, I'm just kidding. None of these sentences are correct. Well, it's all you. जाकी रही भावना जैसी प्रभु मूरत देखी तन तैसी, right? Yeah, space complexity is gonna be big of 1 because we only used one variable just to store the the result. Why I'm laughing? Okay, I don't know. Let's go back to AlgoYogi, mark this solved, and woohoo! See you guys later in the next problem. Until then, bye-bye. I don't know if you have seen this. I shaved my head. Let me update you guys. I shaved it like a month ago. Since then I have been putting on my cap so that I could hide my embarrassment. All right. See you guys later. Bye-bye.